Hey everybody. So today we're going to do what I'm going to call max to min problems, which are basically problems where instead of giving you a graph, I'm going to give you just a little bit of information about a graph. I'm going to give you one maximum and one minimum, and that's actually going to be enough information for you to figure out the total equation of the graph. So I have an example problem right here, and I'll read it out loud. Sinusoidal function f of x. Sinusoidal just meaning that this is a graph that is a sine wave or a cosine wave. Sinusoidal can describe sine waves or cosine waves. Sinusoidal function f of x has a point of maximum, so a high point, at the point 3, 10. X is 3, y is 10. And then the subsequent point of minimum is at 9, 2. Just as a by the way, this wording, the subsequent point of minimum, you'll see a lot, because since sinusoidal functions repeat themselves over and over and over again, there's going to be infinitely many points of maximum, infinitely many points of minimum. So we're just going to focus on one of the maximums and the subsequent point of minimum. That means the very next point of minimum. So if you have one of these problems where you have a maximum and a minimum, what I would recommend you do is sketch a little graph for yourself of what's going on. So I'm going to, as usual, draw an x-axis and a y-axis. And I'm going to try to label these points here. So the first point is at 3, 10. So I'll call this an x of 3. I'll call this a y of 10. And so that's a point of maximum. Something you'll likely find useful is draw yourself a line at that maximum. So we know that the maximum output is 10. We have a point of maximum at a y of 10. So we've got that point 3, 10. All right. Oops. I'll just make that my 3 then. All right. And so then we also have a point of minimum, the very next point of minimum, at 9, 2. So I'll call this an x of 9. I'll call this a y of 2. So there's our point. And again, I'm going to sort of draw a line just so that that minimum is really clearly labeled. So our minimum here is at 2. Okay, so we have just 2 points on this graph. And we know that sinusoids go forever and ever and ever, so we can basically connect these 2 points, saying, okay, it's going to sort of curve between these 2 points. And then we expect that the graph is just going to go on and on and on, that it'll like go back up to a maximum, and then it'll go back down to a minimum, etc. But this graph goes forever and ever and ever in both directions. All we have now are 2 points on the graph, but that's actually plenty to find the whole equation of the graph if we just sort of think through the graph's properties. So one of the things I'll point out is whenever you have a maximum and a minimum, it's really easy to get the equilibrium line, because that's just the average of the maximum and the minimum. So if my max is at 10 and my minimum is at 2, the average of those 2 values, the equilibrium line, must be at 6. So I got that by just adding 10 and 2 together. 10 plus 2 is 12. 12 divided by 2 is 6. The average of those 2 values is 6. So I've got that my equilibrium is 6. And from there, it's actually pretty easy to figure out my amplitude. The amplitude for this graph is just how far above and below equilibrium you go. The amplitude for this graph is 4. Okay. In terms of the period of this graph, well, let's think about the information I have. I was given 1 point of maximum, which was at an x of 3, and 1 point of minimum, which was at an x of 9. So I have basically part of a period. What I want to point out is that's not a full period. It's not a full cycle, because I don't yet see the graph repeating itself. I've basically gone from the top to the bottom. To finish out a full cosine cycle, I would need to get back to the top. Like I would say that when the graph starts repeating itself, when you've gone from the top to the middle to the bottom, back to the middle, back to the top, this would be 1 full cycle. This would be 1 full period, because you see that you have 1, 2, 3, 4 quadrants. You've gotten a full repeat of itself. So here's a cool fact that you can use. If you think about how far away the maximum is from the minimum, if you say, okay, I had to go from 3 to 9, I had to travel 6 units to get from the top to the bottom. Because these graphs have nice symmetry to them, I would expect that I'd have to go another 6 units to get back up to the top. So if you think about it, it was 6 units to get to the bottom. It's going to be 6 units to get back to the top. This has got to be 6 after 9, this has got to be 15. You also could think about sort of what the quarter period is here. It turns out the quarter period is 3. So 3, 3, 3, 3. So what I can now do is I can identify the length of the period, the length of a full cycle. It goes from 3 to 15. The length of a full cycle is going to be 12. The period for this graph is 12. Max to min is exactly half a period. So if you had to go 6 units to complete half a period, the full period is 12. And so then when I get the b value that's in my equation, the b value will be 2 pi divided by the period. So the b value that I want in my equation is pi over 6. All right, so I'm actually all set to write my equation now. As you guys saw in our last lesson, you can actually write any sinusoidal equation in terms of sine or negative sine or cosine or negative cosine. What I'll say with max and min problems is usually the easiest choice is just cosine, because cosine starts at a max and negative cosine starts at a min. So if I wanted to write this as a cosine equation, I would say that the equation of this graph is y equals an amplitude of 4 times the cosine of my b value is pi over 6. Then I can have x minus wherever a cosine cycle starts. I have a cosine cycle starting at a point of maximum. At x equals 3, a cosine starts. So I can do x minus 3. Remember, because inside the function is counterintuitive, if your cosine cycle starts at 3, you want a shift of x minus 3. And then lastly, I just need to tack the equilibrium onto the end. I think I have just enough space here. The equilibrium line is going to be plus 6. So I did not leave myself a lot of space there, but I was able to get it all in. That is an equation for this graph. It's not the only equation for this graph. This graph has infinitely many equations. If I was to write a different equation, for instance, I could write one with a negative cosine. A negative cosine will just have a negative in the front, right? It's a negative cosine. Every other property will be the same. So amplitude is still 4. I'm doing negative cosine. My b value is still pi over 6. It's just that my shift will be different with negative cosine. For negative cosine, I want to shift to the start of a negative cosine cycle. So because I put a negative out front, I need to shift to the start of a negative cosine cycle. A negative cosine cycle starts at its minimum. I see a point of minimum here at 9. So like this is the start of a negative cosine cycle. It'll last 12 units. So since the negative cosine cycle starts at 9, this would be x minus 9. So that's also an equation for this very same graph. All these maximum minimum problems will pretty much be set up the same. You'll have a point of maximum, a subsequent point of minimum. You'll draw part of the graph, and then you're probably going to want to finish off at least one period. So you can say, okay, I was given half a period. Let me see what a full period looks like so that you can write the equation. All right, we'll do one more example together, and then you're going to do some practice problems today. So let's say for our next graph, we were given the following information. Let's say I told you that there was a sinusoidal function and it had a point of minimum at the point -4, 11. So that's an x of -4 and a y of 11. And I'm going to say that the subsequent, the very next point of maximum is at the point 10, 15. So that's our point of minimum. That's the subsequent, the very next point of maximum. We're going to find an equation for this function. We're going to start, however, by drawing a picture. So I'm going to draw my x-axis and my y-axis. And I'm going to try to label these points. So this is the point x is 4, y is -11. So I'm going to label for myself, here's -4, here's 11. Actually, you know what, since that's a minimum, let me put it a little lower for you guys. I want to have room for my maximum also. Let's call this 11, just so we have space. Okay, so here's my point, -4, 11. That's a point of minimum. And just like last time, I'm going to draw a line here at the minimum, so I've got that for reference later. So that's my minimum line. And then my maximum is all the way over at an x of 10 and a y of 15. An x of 10 and a y of 15. So I'll call this an x of 10, and I'll call this a y of 15. So I got part of my graph. I basically have a graph that's got to sort of like go up to that point. Okay, so I know that on its way up, it's going to cross the equilibrium line. The equilibrium line is at the average of the maximum and the minimum. So I'm just going to add those up and divide by 2. 15 plus 11 adds to 26. 26 divided by 2 is 13. That makes sense. That's right in the middle of 15 and 11. So I'm going to say my equilibrium line is at y equals 13. That's the average output for this graph. And that must mean that the amplitude, the maximum deviation from that, is 2. The graph stretches 2 above and 2 below. In terms of the period for this graph, remember, the distance between a minimum and a maximum is always half the period. Because if you want to have a full negative cosine cycle in this case, I need to get from minimum up to maximum, and then I've got to get back down to minimum. I've got to finish out a full cycle. So if I went from -4 to 10, if I went 14 units here, I've got to go another 14 units to get to the end of the cycle. So the distance between -4 and 10 is 14, so I need to go another 14 up to get here. That's going to be an x of 24, right? This is a distance of 14. I added another 14. What's important is the total period, the total length of a cycle. So if I want to know how long it takes to complete this full negative cosine cycle, to go through 1, 2, 3, 4 quadrants, a full cycle goes from -4 to 24. The full cycle is 28. You can always just double the distance between your maximum and your minimum to get your full period. Since the minimum and the maximum were 14 apart, the full period was 28. That was the distance to complete a full cycle, which means my b value is going to be 2 pi divided by 28, or pi over 14. And when I go to put my equation together here, I totally have the option to do it in terms of whatever type of trig I want. I'm going to say that I want to focus on this point of minimum, because that's the start of a negative cosine cycle. So I think that's going to be the easy equation to write for now. So I'm going to start to write the equation here. I'm going to put a negative out front because I'm doing negative cosine. I just need to sneak the amplitude in there. So the amplitude is 2. This is going to be -2 times the cosine of pi over 14 as my b value. I'll put a shift in there in just a second. Let me get my equilibrium in the back. Equilibrium is 13. Okay, so just remember, whenever you're writing your shift, it's counterintuitive. So I had a negative cosine cycle start at -4. So instead of x minus, this one's actually going to become x plus 4. Inside the function is counterintuitive. So if your cycle starts at -4, you want your shift to be x plus 4. That's what would allow the cosine cycle to scoot backwards to -4. So this equation here represents this graph. For all of these maximum minimum problems, just draw yourself a picture, figure out your equilibrium and your amplitude, and the big thing to remember is that the distance between a maximum and a minimum, you need to double that to get the period, because this is only half of the whole cycle. You need to go the rest of the way to get the full cycle. All right, good luck.